Alright, this question says a line passes through the point together with the x and y axis and forms a triangle in the first quadrant. Find the x-intercept and the area of the triangle if the triangle has the least possible area. Now, first thing is, this question looks funny. I don't know what to do. I don't know what to do, but let's just break it down, right? We need to break it down. First thing it says is find the x-intercept. X-intercept. I know something about x-intercept. X-intercept is when y is 0. So let's call this point that we're going to have to find. I'm going to use M, the letter M. I hope that's okay with you. And I noticed something. This straight line, I would also, this point right here is the y-intercept, I'm going to call it M. Yeah, I'm calling that point M. Now, look at this now. The equation of any line, let's say we have a line y equal to 3x minus 6, right? What do you notice about this line? This line right here, we would know that the y-intercept would be when x is 0. When x is 0, that's negative 6. And if you wanted the x-intercept, that's when y is 0, x would be 2. 3 times 2 minus 6. That's still 0. Now I'm going to show you something really amazing. The equation of any line can be written in this form. The equation of any line can be written as x over the x-intercept plus y over the y-intercept equal 1. The equation of any line can be written in the form x over x-intercept plus y over the y-intercept equal 1. Example, if you're supposed to use this one, this line y equal 3x minus 6. You know, say have a gradient of 3 and pass through minus 6. See here, minus 6 passes through 2 this one. Look at this. If we use this way at the equation of the line, it would just be x over the x-intercept 2 plus y over the y-intercept negative 6 equal 1. Now if you multiply 2 by negative 6, that will give you negative 6 times this right here, that would be negative 6 times x is negative 6x over 2, that's negative 3x. Then negative 6 cancel that plus y equal to negative 6. And then we'll bring over the 3x to get y equal to 3x minus 6. That's amazing. Imagine that. So see here, we can start from this and get this by using this equation. They're exactly the same. They're exactly the same. Alright? So they're exactly the same. Since they're exactly the same, now we're nice, right? So now we can find the least possible area. Now we're just going to start with this equation right here to do this question. Alright, so now we're going to start with this now. So now we know that this point right here we're calling the x-intercept. Let x-intercept be m0 and let y-intercept be 0n. So using the equation we just found out, it is going to be x over m plus y over n equal 1. That's the equation of that line. This is the equation of the line over there. Now, if this is the equation of the line, then any point on the line satisfies the equation. If this is the equation of the line, any point on the line satisfies the equation. So now we can say at P, and P is the point 1, 4. So X is 1, Y is 4. Plug in it. X is 1, Y is 4. That equal to 1, though? Yeah, man. Now look at this. If this is what we have now, we can write this as one fraction, just to look a little bit better. Multiply, well, write it as one fraction first. And then we'll cross multiply with n plus 4m equal nn. Now, what I'm going to do is, we usually want y in terms of x, don't it? So y would be corresponding to n. So I'm going to make n the subject, n minus, bring over this mn equal to negative 4m, n, factor that out, that's 1 minus m. So this is telling me n is equal to negative 4m over 1 minus m, which is the same as 4m over n minus 1. So that's what I get for n. N is 4m over n minus 1. Why is this important? This is extremely important now, because look at this. Now if this is n, right? The area of the triangle now, the area of the triangle is equal to half base times height, don't it? That's the area of triangle, half base times height. Now if the area of a triangle is a half base times height, what is the base of the triangle? The base of the triangle is m. And what's the height of the triangle? N. So we can just put area of the triangle is now half the base. The base is m times the height, which is n, but n is this, 4m over m minus 1. Yeah, man, so that's the area of the triangle. Now, if this is the area of the triangle, we can write this as a function of m. So this is the area of the triangle as a function of m. So now the area of the triangle is just 4m squared over 2 times n minus 1. That's the area of the triangle so far. So now we're good. That's the area of the triangle. Now that this is the area of the triangle, what else can we do now? Well, they told us that we need the least possible area. If we need the least possible area, that means that dA by dm have to be 0. Yeah, that makes sense? And in this case, we can even go further and tell let's say d2a by dm squared going to be greater than 0 in order to make the area be the least possible area. So first, if dA by dm equals 0, put that here, so. Yeah, man. So now dA by dn is 0. Plug that here now. So we're going to work out dA by dm. So dA by dm is, we differentiate this. We're going to have to use, let's use quotient rule. We start with the bottom. Minus times the differential of the top. We differentiate 4m squared, that's 8m. Minus the top, 4m squared. Times the derivative of the bottom, which is 2, over the bottom squared, which is just 2m minus 2 all squared. So dA by dm is equal to, we can expand that out right here. This is going to be 8 times m is 8 times 2 is 16, so that's 16m squared minus 16m. This is then minus 8m squared over 2m minus 2 all squared. Now if this is equal to 0, 16 minus 8 is really 8m squared minus 16m over 2m minus 2 all squared equals 0. If this is 0, then that would mean that we can say that 8m squared minus 16m is 0. We can divide through by 8. We're going to get m squared minus 2m is equal to 0. Now we're going to factorize we're going to get n equals 0 or n equal to 2. No, n can't be 0. Why n can't be 0? Look back at the graph. If you go back to the graph right there, n can't be 0. N can't be 0, it can't be so, and then this point is 0. So this has to be 2, n equals 2. Now since n is equal to 2, let's finish it off. So now we found that n is 2. So we found that n is equal to 2, right? So since we found that n is 2, this is the point 2, 0. So we're nice. So now we just need to know what is n, so we can find the x-intercept, so you can tell them one answer is found. X-intercept is 2, 0. Now just need to find n. There are two ways we can find n. What we do know is the gradient from this point to this point must be the gradient from p to n. That makes sense because the 3 points lie on the line. So this is how we're going to say it. The gradient of Pn must be equal to the gradient of Pm. So the gradient of Pn would be y2, which is, we don't know that y value. The y value is n minus 4 over x2, 0 minus 1, must be equal to the gradient of Pm, and this gradient is 4 minus 0 over 1 minus 2. We can use this and solve for n. This is 4 over negative 2. Well, 4 over 1 minus 2, that's negative 1. This is 4 over negative 1. That's negative 4. And this is now n minus 4 over negative 1, which is just 4 minus n. So I end up getting n equal to 8. When I bring over that, n is 8. So n is the point 8. So that means the y-axis intercept, since n is 8, just to finish it off up here, alright, so the area of the triangle, we're going to finish it in this box. So this is finally, the area of the triangle is equal to half the base of 2 times the height of 8. And so that is just half of 2 is 1. 1 times 8 is 8. So the area is 8 units squared. So that's the least possible area. And that's the x-intercept. That's how math is beautiful. So I really hope this was entertaining. It was very entertaining. I hope you had fun. Nice.